Well, sorry not to be with you in person as I'd hoped would be the case when I moved out here, and maybe someday again. Nice to see a lot of old familiar faces, lots of unfamiliar ones who I'd like to have a chance to meet someday. Well, time is brief. There's a lot that I'd like to cover. I'll have to keep to a rather sketchy, informal account. The long-term goal of theoretical inquiry is explanation, which is not a trivial concept. I'll try to clarify as we proceed. We, of course, want to distinguish explanation from description. Descriptive inquiries seek to show that this is the way things are. Explanation goes far beyond, seeks to show why things are this way and, crucially, not some other way. It's a much more ambitious endeavor, but it is the goal to keep in mind. Actually, it's not a completely sharp distinction. There are ways in which description can yield explanation. That can happen if there's a definite method that leads to the description. One can then inquire into how that method fares in other cases. There's one very familiar example, structural linguistics. In its most sophisticated form, it was based on fairly well-defined procedures of analysis that could be applied to any collection of linguistic materials. We can therefore test the procedures on possible and impossible languages. If they make the distinction properly, we would be approaching answers to the deeper why questions. It can, however, be easily shown that they work just as well for impossible as for possible languages, and therefore they don't really tell us anything about language. Now, that was not a problem at the time, because it was assumed that languages could vary basically without limit, and that they were acquired by training, more narrowly by conditioning. It's now well established that none of this can be sustained. There is a very clear contemporary analog. It's the enthusiasm for deep learning, like the state-of-the-art GPT-3 system of language processing that makes headlines because it can produce text that looks like actual language. And we can ask the same question: how does it fare with impossible languages? Answer is the same. Does it just as well or better by systems that violate the basic principles of language? So therefore, this multi-million-dollar deep learning neural network trained on a 45 terabyte corpus of text and running on the world's largest supercomputers is telling us nothing about language. And it's actually a fair question whether it's doing anything at all, apart from using a lot of California's energy. And then there's GPT-4, which is going to have 100 trillion parameters. Will use a lot more energy, will tell us just as much about language for the same reasons. Some of you may have heard a story about John von Neumann and Freeman Dyson, great physicist. Freeman Dyson is supposed to have come to him with a new idea which had dozens of parameters. And von Neumann told him, look, with 4 parameters, I can conjure up an elephant. With 5 parameters, I can get it to whistle, go home and figure out what's happening. Well, whether the story's accurate or not, the point is real. I won't pursue this issue here, but along the same lines, we can show, I think, that virtually all of the popular description approaches to description of language fail radically in the same way. And I think those are matters that are worth some thought. I won't go into it now. Let's just keep to language. In the case of language, inquiry proceeds at 2 levels. One level is concerned with individual languages. The second, higher level, is concerned with the general faculty of language, FL for short. FL is the innate endowment that allows a language to be acquired and used. Well, at the first level, study of individual languages, inquiry seeks a grammar of the language, a description of the properties of the language. An adequate grammar must, at the very least, provide a recursive enumeration of the grammatical sentences of the language. Beyond that, it must yield what has been called the basic property of language, a digital infinity of hierarchically structured expressions, each of which determines or perhaps constitutes a thought, each of which can optionally be externalized in some sensory motor medium. A bold thesis would be that generation of thought by the internal language is separated from externalization, an ancillary process. I'll tentatively assume this, return to reasons why I think it's correct. In this conception, the internal language consists of the compositional rules that satisfy the basic property, along with what's called formal semantics, more accurately, logical syntax, term that Danny Fox used years ago. That's an important matter, I'll put it aside. One version that fits closely with the theoretical framework I'll be outlining here is the kind of neo-Davidsonian event semantics. It's been developed most extensively by Paul Petrosky, Barry Shine, but other options do as well. The system for generating thought we can call I language. I here stands for internal, individual, and intentional with an S, meaning that we're interested in the actual system coded in the brain, not just one that yields the same output. Well, understood in this way, language conforms to a long tradition. Goes back to classical India, classical Greece, runs through the 19th century. Throughout, the core of the tradition regarded language fundamentally as a system of thought, as audible thought, in the phrase of 19th century linguist William Dwight Whitney. We now, of course, know that restriction to sound is too narrow. The tradition was swept aside in the 20th century by behaviorist structuralist approaches, and the rich tradition was forgotten, totally forgotten. These modern approaches take language to be at its root a system of communication rather than as a system of thought, as in the tradition, perhaps evolved from animal communication. There were reasons for the shift. I don't think they stand up well on analysis. It's an interesting story that I'll have to put aside. Recent work seems to me to indicate that the tradition was on the right track and should be carried forward. That's a highly controversial view today, but I think it's justified, and I'll adopt it here. Well, turning to explanation, the task arises only at the higher level, inquiry into FL. FL must at least explain how language is acquired. It appears to be the case that any human infant can acquire any language with comparable facility. There's by now substantial evidence that FL is unique to humans, that its fundamental properties have no analog in the animal world. If these empirical assumptions are correct, as appears to be the case, then FL is a true species property, shared by humans, unique to them in essentials. I'll also assume that in what precedes. So FL must at least provide an explanation for how any human infant can acquire any language. It's a condition that's been called explanatory adequacy since the 1950s, sometimes called Plato's problem, as the problem was formulated by Bertrand Russell quite generally. It's the problem of how we can know so much given so little evidence. In other terms, it's the problem of poverty of stimulus, POS. In the early days of the generative enterprise in mid-20th century, it was recognized that the POS problem was quite serious and that standard formulas, training, habit, conditioning will get nowhere. Much the same is true of their contemporary variants. These earlier conclusions were established much more firmly as serious experimental inquiry was undertaken in later years into child language acquisition. It was found that the problems of POS are far more severe than had been assumed. By now, it's been quite solidly established that the knowledge of language of a 2 to 3 year old children goes far beyond what they exhibit in behavior, and also, crucially, that the gap between data available and knowledge attained is vast, greatly deepening Plato's problem. Well, these results seem to suggest that FL must be quite rich to yield complex knowledge from impoverished data, while at the same time, FL must somehow accommodate the wide variety of languages. That's a problem. The problem deepens when we turn to another condition that FL must satisfy, sometimes called Darwin's problem. How can FL have evolved under the conditions of human evolution? Well, evidence about that is fragmentary, but there are some plausible conclusions about these conditions. Modern humans appeared maybe 200,000 to 300,000 years ago. There's now genomic evidence that the small group of humans began to separate on the order of 150,000 years ago, plus or minus. They share FL, which was presumably already in place. Prior to the appearance of modern humans, there's virtually no evidence of significant symbolic activity in the archaeological record. Not long after their appearance, there's very rich evidence. Note that these numbers are barely a flick of an eye in evolutionary time. Well, all of this suggests that the faculty of language appeared in a very narrow window of time, pretty much along with modern humans, hasn't changed since. If that's the case, we'd expect FL to be very simple. Well, we now face a conundrum. FL must be rich enough to handle Plato's problem, at the same time simple enough to deal with Darwin's problem, and the apparent wide diversity of languages, all determined by FL, lurks in the background. Many problems. These are the basic conditions that must be satisfied by the theory of FL, what's called UG, Universal Grammar and Contemporary Usage, that's adapting a traditional term to a new context. The conditions appear to be contradictory, and much of the search for explanatory theory in the past years has been guided by this apparent contradiction. Well, for the first time, I think we can now begin to see how the conundrum might be resolved. Let's turn to that. Let's begin with the problem of diversity. That problem would be greatly reduced if diversity of language is sequestered in a particular component of the overall system. The natural place to look is externalization, that is, excluding the I language operations that yield the thought system. That move has initial plausibility. For I language, the POS problems are overwhelming, generally, literally insurmountable. For externalization, at least there's direct evidence, what's heard and seen, though this hasn't been firmly established by any means. Research has tended towards showing that the variety, complexity, easy mutability of language is indeed sequestered in externalization, leaving generation of thought relatively fixed, maybe completely fixed. We may someday discover that would vindicate an ancient tradition going back millennia. Well, if this turns out to be true for language, it would not be very surprising. Externalization is not, strictly speaking, language. Rather, it's an amalgam of the internal system for generation of thought and sensory motor systems that have nothing to do with language and were in place long before language appeared and haven't changed with the appearance of language. So we might expect then that the mapping of the internal system into completely unrelated sensory motor systems would be a complex task, solvable in many ways, easily subject to at least superficial change. And so it seems to be. Well, if this is basically correct, we then face the POS problems for externalization. This has been the subject of extensive, very interesting research, basically for the past 40 years, since the principles and parameters framework was formulated. It was the first approach that offered at least a potential framework for accounting for acquisition in a feasible manner. And there's been very important work since, primarily by our late colleague, Ken Hale and his students. They've shown that languages that appear to be radically different on the surface are actually cast to the same mold at deeper levels. One high point in this research was Mark Baker's work on hierarchy of parameters. Another major step forward was taken later by Ian Roberts. He's shown quite persuasively how very simple algorithms based on elementary cognitive principles can feasibly zero in to the choice of parameters for particular languages, the parameters that determine an externalization system. Tested the approach with thousands of languages of wide typological variety. It's important work. Dave Lightfoot has developed a promising approach from a somewhat different point of view. I think it's fair to say that the basic problem of variety of externalization systems is fairly well in hand. And if externalization is the primary, maybe even the only locus for variation, large part of the problem of the conundrum is on its way to resolution. Variety, unlearnability, Plato's problem. Well, to proceed further, be helpful to turn to some concrete examples. I'll begin with the most fundamental property of human language, one that's quite surprising in many ways, has rich consequences that are not always sufficiently appreciated. I'm referring to the property called structure dependence. So to refresh memories, let's look at some simple cases. So begin with the operation of construal. For example, modification of a verb phrase by an adverb. So examples are simple enough, so I won't have to go through the pain of trying to share screens. Just take the sentence, the guy who fixed the car carefully packed his tools. It's ambiguous. He could be fixing the car carefully, could be carefully packing his tools. Put the adverb in the front. Carefully, the guy who fixed the car packed his tools, unambiguous. Carefully packed the tools. That poses a puzzle. The adverb in initial position has to find a verb phrase to modify, but we ignore the simplest computation. Find the closest verb phrase. That would be fix the car, but reflexively, we ignore it and we choose the more remote verb phrase, pack the tools. It's perfectly clear why if you look at the structure of the sentence. The phrase packed his tools is actually closer to the adverb than fixed the car in the abstract structure. That's what we attend to, though we never hear it, of course. You don't hear structures. There's more involved in this, and it's interesting, but this is enough to bring out the basic puzzle. We ignore the simple computation on linear order of words. We reflexively carry out a computation on abstract structure, example of structure dependence. Well, take another example, anaphors. Terms that lack independent reference have to seek an antecedent, as in the boys like each other. Simplest algorithm is to seek the closest possible antecedent. Usually works, as in the boys expect the girls to like each other. It's the girls who like each other, not the boys. But sometimes it fails, as in, say, the friends of the boys like each other. Here it's the friends who like each other, not the boys, the more remote antecedent. Well, once again, we reflexively ignore the simplest algorithm, which relies on what we hear, words in linear order. We use an algorithm that applies to abstract structures, and it's pretty complex. First, have to identify the subject noun phrase, then the core element within the noun phrase, and choose that as the antecedent. Much more complicated than pick the closest antecedent. Well, take a last example, verbal agreement. Take the bombing of the cities is a crime, not are a crime. The bombings of the city are a crime, not is a crime. Again, reflexively, we ignore the simplest operation, adjacency, and we carry out an operation that looks quite complex. Construct the abstract structure, subject predicate, and locate the head of that structure, all instantaneous and reflexive. Well, the observations generalize. Structure dependence holds of all constructions in all I languages. That means that from infancy and on through life, we reflexively ignore 100% of what we hear, words in linear order. We attend only to what we never hear, abstract structures generated by the mind and operations on these structures. Furthermore, experimental work has now shown that the principle is known to children as early as they can be tested. 2 years old or less. The champion at the moment is 18 months. Notice that this curious property, and it is curious, is restricted to I language, generation of thought. Principle, of course, does not hold for externalization. There we often use the simple algorithms. Well, there's only one plausible conclusion. I language and externalization are distinct systems. For I language, efficient computation ignores what is externalized. This conclusion further supports the thesis that I language, that is, language proper, is a system of generation of thought, as had been assumed in the millennia-old tradition prior to the behaviorist structuralist revision in the 20th century, which I think we can increasingly see was a pretty sharp departure from science. Controversial view and a minority view, but I think it's correct. Well, it's plain why languages use linear order for externalization. It's required by the speech organs, which cannot produce structure. In fact, sign language, which has the resources of visual space available, does not adhere strictly to linearization, uses the resources of that sensory motor system. Well, recall that the sensory motor systems used for externalization are completely unrelated to language in their nature and their evolution. It's not surprising then that I language, which is pure language, ignores the properties that are imposed by these non-linguistic organs. Well, with this in mind, we can turn to the why questions. Why does UG force structure dependence? The optimal answer would be that this follows from the simplest form of UG, the form that uses the simplest operation for generating expressions. The simplest operation is unbounded binary set formation, what's called merge in the literature. And in fact, structure dependence does follow directly from merge. To put it metaphorically, when Mother Nature created language, she found the simplest possible solution, which incidentally is the way evolution works quite generally. Reliance on merge as the sole structure building operation has many other crucial empirical consequences. I'll only be able to sketch a few in the time available. There's more in the background paper that was circulated, but I'll add a warning that background papers from a couple of months ago, things are moving fast. Some of the things in it are wrong, can be improved. I'll mention that soon. Reliance on merge as the sole structure building operation, first of all, yields the core of the basic property, generating an infinite array of hierarchically structured expressions. We need only add that any computational procedure will have primitive elements And in this case, we will take the primitive elements as elementary concepts, obscure notion, come back to that. Elaborated by merge, these elementary concepts become phrases. At this point, we can translate directly to event semantics. These phrases would be the syntactic exponents of participants in events. A program along these lines, if it could be fully carried out, would complete the theory of generation of thought, externalization as an ancillary system, a very interesting system, many interesting properties, in part determined by the abstract I-language structures that externalization maps to the sensory motor system. You're familiar with this. I should add that the evolutionary origin of the most elementary concepts that serve as primitives is a complete mystery. They have no analogs in the animal world, and there's no record of their development, and we can't find any. Those who are interested in evolution of language would do well to read carefully the article on evolution of cognition generally by the late evolutionary biologist Richard Lewontin in the MIT Invitation to Cognitive Science. He runs through what can in principle be learned by any known methods of evolutionary biology. And he concludes that for many questions that we might be interested in, the answer is tough luck, his phrase. We can construct stories, but no answers for them. Sorry to say that this lesson has not been well learned, and there's a huge literature that overlooks it, but we should pay attention to it. There are two logical possibilities for merge of X and Y. Either the two are distinct or one is a term of the other, where A is a term of B if A is a member of B or a member of a term of B, continues recursively. The two options are external and internal merge. External merge yields combinations, as in read books. Internal merge yields displacement, as in which books did he read, where which book is understood to be the object of read. In the past, it's been assumed, by me in particular, that combination by external merge is the expected natural operation, and that displacement, while ubiquitous, is some kind of anomaly of language, an imperfection that has to be explained away somehow. Well, that turns out to be a mistake. In fact, it's internal merge, displacement, that's the preferred operation, requires far less search than external merge. The real question is why language ever resorts to external merge. The answer presumably lies in the fact that I-language generates thoughts. It must therefore provide structures in which semantic roles are determined, theta theory and technical terminology. Takes a little work, but it can be shown that this can only be done by external merge. Therefore follows that both displacement and combination will appear in an optimal system, the two subcategories of merge. Assuming that merge is optimal, it will never change the terms to which it applies. In particular, it never erases them. So this is a general property of computation. So to take an example with an interesting history in the history of mathematics, you can't assume that in one line of a proof, 0 means 0. And somewhere later in the proof, zero means as small as possible. There's a huge debate in the history of mathematics as to whether Newton's proofs were valid because of this possible equivocation. But in any event, it's a condition on computation that you can't change the interpretation of a term in the course of the derivation. Well, applying to language, it's what's called the no tampering condition. In particular, one particular case is that the derivation can't erase a term. That radically changes it. So that means generation of which books did you read actually yields which books did you read which books. That's interpreted directly as something like for which books X you read the books X. So merge, therefore, automatically yields the phenomenon of displacement with reconstruction, but without reconstruction. It's a topic that's been extensively studied, falls out directly from the optimal system of generation, many interesting consequences when you pursue it, just as structure dependence does. So what reaches our mind in this case is which books did you read which books, but what reaches the ear and reaches consciousness is which books did you read. Externalization removes all but one occurrence. One occurrence has to remain to indicate that the operation took place. That's a general economy condition. It radically reduces mental computation and the execution of articulatory motions. Notice that what we call inner speech is actually externalized speech. In fact, when you look closely, fragments of externalized speech. What's going on in our minds is inaccessible to consciousness, just as we have no conscious insight into the workings of other parts of our body. We can only study them from the outside, from what philosophers call a third-person perspective. The mind is very much like other organic systems in this respect. Well, the result of these operations is to maximize computational efficiency while yielding problems for perception and parsing, what are called filler gap problems, major problems. The parser, perceiver, finds a WH phrase, like which books, and then has to find a gap that it fills for interpretation. That turns out to be quite complex, probably the main problem in automatic parsing. The problem would be radically reduced if the gap were filled, but Mother Nature didn't care about that when designing language. She insisted on finding the most elegant solution, even if it happens to pose difficulties for language use, quite serious difficulties as sentences become more complex. Now, this is one of the many cases in which computational efficiency conflicts with communicative efficiency. Invariably, communicative efficiency is sacrificed. That's, when you think about it, that's more evidence for the traditional conception of language as fundamentally a system of thought, of course, used for communication and much else, but these are incidental properties, contrary to modern dogma. Notice that all of this is quite consistent with how evolution proceeds quite generally. So schematically, we can distinguish three stages in evolution. First stage, some disruption takes place accidentally, randomly, maybe a mutation, gene transfer, or a bacterium swallowing another microorganism. That was the breakthrough that led the way to complex cells, complex life. That's the first stage. Second stage is reconstruction. Nature reconstructs the new entity in the simplest way, paying no attention to how it might be used, which it can't know. Then comes the third stage, winnowing. The outcomes that reproduce more effectively prevail, natural selection. That, the most interesting stage is the middle one, reconstruction. That suggests a reasonable scenario for language evolution. First, some minor rewiring of the brain took place, yielding the new property of recursive enumeration. Perhaps the rewiring was along the lines suggested by neuroscientist Angela Friederici. She's produced interesting evidence. Bob Berwick and I discussed it in our book a couple of years ago. She's produced evidence that language competence correlates with the closing of a circuit of dorsal and ventral connections between the two main language-related areas of the brain. It's a neural property unique to humans. Well, that's a possibility for the first step. Next step is reconstruction. Nature devises the simplest and most elegant way to organize the new system. That's the core of the problem of explanation in language. Then theta theory becomes available, possibly with more primitive origins. Maybe notions like actor, action, schemata, or something like that. The computational principles are just given. They're part of natural law. Just take them off the shelf for free. The winnowing stage is apparently never reached, possibly because of lack of time, possibly, more interestingly, because the optimal system is so delicately designed that it's either all or none. That might turn out to be the case. I think recent work again is tending in that direction. Well, we're approaching an interesting conclusion, not reached, but approaching. You can see it. I language might be perfect and a common human possession. That was actually proposed 25 years ago. It was called the Strong Minimalist Thesis, SMT. It was not then regarded as a realistic thesis, rather as a long-term goal that might guide research. Recent work suggests something more audacious. The thesis might be true, as evolutionary theory leads us to expect, and empirical inquiry increasingly suggests. There's a good deal of further evidence for these conclusions, not a lot of time. I'll give a couple examples. To take one case, consider the distinction between trace and pro, keeping to earlier terminology now abandoned. The distinction is illustrated in sentences such as these from 40 years ago. Take the sentences, one interpreter each seems to be assigned to the visitors. Okay, one interpreter each tried to be assigned to the visitors. No good. Both sentences are fine if you drop the word each, but the second one with try is barred with each present. One interpreter each tried to be assigned to the visitors. The reasons are given by simplest merge. The good sentence with seems is generated by internal merge. Therefore, what appears in the trace position is actually one interpreter each. So what's reaching the mind is one interpreter each seems one interpreter each to be assigned to the visitors, and one interpreter each seems to be assigned to the visitors is fine. You can't do that with try. There, the matrix subject position has to be filled by external merge of an element, and therefore there's no reconstruction, and the sentence with each is barred. Well, there's a good reason for this. It's a general condition on valid computation, holding for language and everything else. An inscription cannot change an interpretation in the course of computation. What I mentioned before, it follows that internal merge cannot move a term into a theta position where a semantic role is assigned, like the subject of try, that would change its interpretation. That position must be filled by internal merge, by external merge of an element that had no prior interpretation, so it's not changing. Well, internal merge, however, can move an object to the subject of seem, where no semantic role is assigned, as in one interpreter each seems to be assigned to the visitors. Well, I'll leave it at that with you, but if you pursue it a little bit, you'll see that these considerations suffice to yield the linguistic system of obligatory control, both subject and object control, a module of I language with their well-known properties, like the trace pro distinction. Nothing has to be said about any of this. All follows from the strong minimalist thesis. Well, at this point, new questions arise. Why does the module of control exist with its curious properties? We actually now have an answer. I language satisfies the strong minimalist thesis, and language uses the options that it provides. Otherwise, there would be no reason for language to have such systems as subject and object control, along with others that are established on the same grounds. Reversing the reasoning, the existence of these systems provides evidence that language actually does observe the strong minimalist thesis, that I language is perfect. No time to go into the details here, but a number of other modules fall into place in the same manner. I'll just indicate briefly. That includes problems that have resisted even description in earlier years. Two examples of that are head raising and sequences. Head raising is constantly used in descriptive work, but illegitimately. There is no such operation within any existing framework. Reasons are explained in the literature. Turns out to be dispensable within the framework I'm outlining. It's discussed in the background paper. That part works. Sequences have been a hopeless problem since the early days of explicit grammar. So take a simple example like Tom, Dick, and Harry danced and sang all night. Both the subject and the verb phrase sequence can extend without limit. Within phrase structure grammar, that would require infinitely many rules. Transformations don't help, nor do any other mechanisms that have been proposed. The meaning of such expressions also raises questions. The sequence, again, Tom, Dick, and Harry danced and sang all night, that accommodates many thoughts. And interpretation is not sequential. The interpretation becomes sequential only when subject and verb phrase have the same number of conjuncts and a phrase like respectively is added. But contrary to what I've assumed in the past, including the background paper, That's a discourse property. It's not part of I language. So we can say perfectly well, Tom, Dick, and Harry are close friends. They even co-author articles. They teach at Harvard, MIT, and BU, respectively. So it's therefore unnecessary to add a rule form sequence, as was done in the background paper. We can keep just to set formation, one of those operations that comes free. Should mention, incidentally, that the interpretations of such things are very complex. Barry Schein has a monumental study, the longest book with the shortest title, called And, which goes into this. But even in the very simple cases, like the one I mentioned, you can see that the problems are quite real. Well, the same analysis applies without change to other kinds of apparent sequences, such as they proceeded step by step by step, lie after lie has eroded the concept of truth, and so on, all fall out the same way, no notion of sequence, just said. Well, in I language, we keep only to sets, yielding the semantic interpretations, the possible thoughts, the array of associated properties that are discussed in the background paper, ATB, lots of other things. They follow at once, but without departing from straight sets. The sets are externalized as sequences for the usual reasons. The non-language sensory motor systems require it. Crucially, I language keeps to the strong minimalist thesis throughout, no departure necessary, both for what appear as sequences and for the amalgamation of heads that replaces the impossible operation of head movement. Well, this scratches the surface. Remains to show how far we can extend such reasoning. Needless to say, that's an extremely challenging task. Nothing like this task has ever arisen in the study of language and thought. There are promising early steps, far beyond what could have been imagined a few years ago. Just to summarize, strong minimalist thesis has several functions. One is a disciplinary function. It sharply restricts the options for description and therefore deepens explanation. It gets rid of the why not questions that are usually ignored. But it also has an enabling function. It provides options for what language might be, for what modules might exist. An interesting question that's just coming into sight is whether I languages make use of all the possibilities enabled by the strong minimalist thesis. If so, that would be interesting. It would be rather natural. Hard question. As for the strong minimalist thesis itself, it may be more than just a guideline for inquiry, as was assumed in the past. It may actually express a fundamental truth about the nature of language and thought, the most distinctive possessions of this strange species of ours. Thanks. Yeah.
Thank you, Noam. We will proceed to take questions from the audience, both in the lecture hall and from Zoom. Enrico will moderate the question. We'll start from the lecture hall. Yes. Did you actually ask?
Hi, awesome talk. I was wondering if you could talk about other tools of biological communication and if they have similarly complicated origins to language. Do you know if they heard me?
Well, every organism that we know of has a means of communication, from bacteria up to humans. Language, of course, is used for communication. I'd say it's a pretty marginal use of language if you think about it. Almost all of language is internal. You can't go for a second without doing what we call loosely talking to yourself. What you're actually doing internally is totally inaccessible to consciousness. I gave a couple of examples. We do fragments of it occasionally come to consciousness instantaneously. And that's what we call, so for example, you can walk into a room, see some friend of yours, remember you wanted to say something to him, you notice that he's sitting at a table with somebody else, and you'd be interrupting a conversation, and maybe the other person wouldn't want to hear it, so you change your mind and say something different. All of this happens in a tiny fraction of a sentence, of a second, way less than anything that can be measured. And it can be much more complex than that. Just think of ordinary situations. There's all kind of internal stuff going on instantaneously. Nobody has a clue how it happens, even what neural mechanisms are involved. Probably not neural nets, they're too slow, don't have enough computational capacity, but it's all going on. Bits and pieces reach consciousness. Occasionally, we're in a situation where we use externalization for communication. Yeah, we use everything else we do for communication too. The way you comb your hair, the way you walk, all of this carries communicative effect. As intentions, you worry about the beliefs of the interlocutor and so on. So there's plenty of things going on in communication. And you can study the evolution of communication. You can do it because there are analogs all throughout the animal world. So it gives you at least a handle. You can start taking a look at how in fact, Darwin did it, how our facial gestures relate to those of apes, let's say, and dogs and so on. That's all a topic. I don't think it has anything at all to do with language, because it seems that language is a totally different system. Part of the reason why the modern period has shifted from thinking of language as a system of thought, as was true for millennia, to thinking of it as a system of communication. Part of the reason, I think, is rooted in Darwin. There is a famous phrase in Darwin, which maybe you learn in high school biology courses, a phrase in which he said, every change, evolutionary change that takes place has to be very slight. You can only have slight changes. If there's anything else, he said, my whole theory collapses. Well, it's been known for decades that that's just not true. And the whole theory doesn't collapse, it just narrows. There are many changes in evolution which are what's called saltational. Tiny changes have big effects. Many cases. Actually, I mentioned one, the accidental swallowing of a microorganism by a bacterium a couple billion years ago broke a structural barrier that had kept all life as bacteria for billions of years. It broke a structural barrier, along with some other changes, led to eukaryotic cells, complex cells, which are the basis for complex life. Well, that's a huge change based on a tiny event. And there are many things like that. This idea that changes can only be slight does lead pretty naturally to thinking of human language as just an extension of the communication systems of animals. But it's a gross error. As soon as you look at the first thing that elementary thing any biology student learns is if you want to study the evolution of a system, you have to begin by finding out what the system is. First, you study the phenotype. To the extent that you understand something about the phenotype, you can begin to ask questions about its evolution. Unfortunately, the field of evolution of language works the other way. You start by speculations about evolution and you don't say much about the phenotype. Who cares? You can't work that way. You have to start by saying, what are the properties of the system? Then maybe we can say something about how it evolved, bearing in mind de Cloanton's warnings, which are very much worth attending to. Anyhow, I think that's one of the reasons for this widespread, by now almost universal belief in philosophy, cognitive science, linguistics, that language is a system of communication that evolved from animal communication. All the evidence is against it. It's completely counter to what we know from biology. But by now it's so firmly implanted that it's just become a dogma. It will take work to get rid of it. The other factor that led to it is just behaviorism. The behaviorist revolution, in my view, counter-revolution, swept philosophy, cognitive sciences, linguistics in the early 20th century. If you think about it, it's very counter to science. It says we have to just look at phenomena and the arrangement and distribution of phenomena. Today it's called data science. You even have a big building on campus about it. In fact, in linguistics, it's sometimes called corpus linguistics. Just look at the data. This is the worst possible way of doing science. You can't imagine a worse way. In linguistics case, any field methods worker will tell you the worst possible kind of data is a corpus. If you don't have anything else, okay, use a corpus. If you have an informant, you can use informant techniques, elicitation techniques, which every field worker is familiar with. Repeat, somebody says a sentence, repeat the sentence, change a word, apply some operation to it, carry out other things to see if it's real. Corpus linguistics operates under the illusion that you're not using intuition, total illusion. You're using the intuition of informants who you don't have access to, the worst possible case. And pretty much the same is true of data science generally. I mean, physicists don't try to discover the laws of motion by taking videotapes of leaves blowing in the wind. If they're in Silicon Valley, maybe they do it that way, but not science. Science wants explanations. So, in fact, a lot of what's done is just thought experiments. Every experiment you do is a radical abstraction from phenomena. And it's not easy to develop a good experiment. You all know that. To develop a good experiment, one that properly abstracts from the highly multivariate nature of phenomena, that's hard. But that's science. There's a famous statement by a Nobel laureate in physics that the essence of science is to account for the complex visibles on the basis of simple invisibles. That's science, at least since Galileo. Behaviorism is the opposite. It says just data science is the opposite. Just arrange the phenomena, maybe you'll find out something, maybe you will, but certainly not the way science operates. And the extent of this dogma is really unbelievable. You take a look at the literature, just keep to language. It's broader, of course. The dogma in structural linguistics was language is a matter of training and habit. If there's any innovation, it's analogy, whatever analogy is. It's Bloomfield. You find it into the late 1960s. So if you read one of the most sophisticated, maybe the most sophisticated work on structural linguistics is by Charles Hockett, good and serious theoretician. He has a book called State of the Art in 1968. Very much worth reading. Incidentally, he says that everything I've been talking about here is what he calls unmitigated nonsense. But it's a very good, and on his grounds, that's correct. But it's a very good description of what structural linguistics was. Training and habit, analogy, arrangement of phenomena, applying procedures, and so on. The modern data sciences pick this up as well. Behaviorism, it's swept all over the philosophical world. The most influential philosopher of language, right in Cambridge, was Van Quine, very influential. In his view, language is a complex of dispositions to behavior brought about by conditioning. For him, operant conditioning. Take a look at the other major figure in philosophy of language, Wittgenstein, the late Wittgenstein. This is mostly aphoristic, but when you look at the aphorisms and try to take them apart, it's pretty much the same. You read his blue and brown books or philosophical investigations where he talks about language acquisition, it's the same. It's hard to find an exception. It's rare that dogmas of this kind have swept so completely over the intellectual world when they are so counter to everything we know about science and have learned about it for hundreds of years. Now, I'll say again, this is a small minority position, unconventional position, but I think it's correct. Anyhow, going back to the biology of communications, fine topic, just has nothing to do with the study of language.
Okay, no, thank you. We also have questions from the Zoom. Enrico, could you? Amir, I think you had your hand up. Could you please ask your question?
Hi, Noam. Thank you so much for this amazing talk. I was really inspired. A lot of things to unpack. I have a question regarding faculty of language that you mentioned. You said it's kind of specific to humans, but I want to kind of maybe argue or ask your opinion actually on this, because I think, you know, if it's specific to humans, like faculty of language, how can a dog, say, understand human instructions in a nonlinear way? Could there be maybe something common between, you know, all species potentially, or many species, that, you know, maybe faculty of thought, faculty of language is kind of something specific to humans for externalization of language of thought? Could that be the case? Do you see it this way, or do you see it in a different way? Thank you so much.
Well, I happen to have two lovable examples right under the desk now. And there are certain words I can't use, like DOG or OUT, or half a dozen other words. because if I do, there'll be a race to the door and some barking. So I have to avoid those. I've, like other linguists who are dog owners, I've paid a lot of attention to the thinking of dogs. I think each of these dogs has about a dozen thoughts in their mind. You can list them. And they have various, they're very clever at developing, at picking out hints from what my wife Valeria and I do, which elicit these thoughts. But that's it. There's nothing more. And there's no way of getting anything more. So it's a system. It happens to use what from our point of view is language, what from their point of view is just some noise that comes out. So there's some noises that come along, and in the midst of one of those noises, there's PLAY, race to the door, you know, but it's not thought in anything like the sense that we understand thought. It's not propositional thought. There's no truth or falsity. There's no inference, you know, and there's no assessing reasons, judging responsibility. Anything we do with language just isn't there. Now, as I'm sure you know, there have been extensive efforts to try to train our closest relatives to see if you can get the rudiments of language. The most extensive study was done was the Noam Chomsky study, which very careful study with very good people. Tom Bever, one of our first students, first class, is a great experimental psycholinguist, one of the people who ran it. Laura Ann Petito, fine psycholinguist, great work on sign language, very good experimentalist. She was the one who actually worked with Nim intensively, Mark Seidenberg, others. For a while, they tried very hard to raise Nim pretty much as an infant would be raised, and to see if they could elicit some kind of language-like behavior. They use sign instead of sound, because the ape can make a lot of gestures, but not very good at articulation. So at first, they thought at first they were getting somewhere. In fact, if you look at the early publications, they were pretty optimistic. Towards the end, the experiment has to end when the ape becomes too aggressive. And it becomes very aggressive at a certain point, had to be, couldn't continue. And at that point, they began reviewing the frame by frame videotapes that they were taking. Turned out there was nothing. The ape had learned nothing. It had learned that if it makes a particular sign in the midst of a series of signs, it'll sometimes get a banana. And the experimenter said, oh, he's asking for a banana, but he wasn't doing anything, just making a lot of signs, and one of them happened to be that one. There are other experiments with apes. It's very hard to know anything about them because the experimenters refuse to release their protocols. So all we have is the anecdotes. In the case where anybody can look at the protocols, there's nothing there. Laura Ann Petito has an article about this where she discusses in detail how they were not even able to get Nim to understand the notion of an object, say an apple. It could learn a bunch of associations with apples, like the knife that you cut it with, or the piece that you left on the table or something, but it could never get the concept apple, and or any human concept. Humans are just different, like it or not. Something happened a couple 100,000 years ago maybe something as simple as what created eukaryotic cells, who knows? But whatever it was, it led to a very different organism with different kind of structures, different concepts that have no analog in the animal world, none of them. And even the simplest, no comparable notion of thought. You can get another, I mean, other animals do extremely complex things, way beyond what humans can do. It's not a matter of, you know, there's no great chain of being with humans at the top. Like I live in the desert ants out in my backyard with practically invisible brains can carry out computations that humans can't mimic, even with complicated instruments, navigational computations, for example. That's the way evolution works, just goes off in different directions. And we're not overgrown apes, we're something else.
Thank you.
We have a question from Margaret, could you?
Hello. Oh no. It's another person. Okay. Hello. Given your take on his corpus linguistics, what is your take on historical linguistics? Because it seems to show some tendencies in how language develops, but we can't extract intuition from speakers who are dead.
Well, there are questions here. One is about the study of earlier stages of language, where of course you have to work with texts that are available. So for example, when Ken Hale, Norman Richards, Jenny Littledoe reconstructed Wampanoag a couple of years ago, they had to work with missionary texts and comparative evidence, and were able to do an amazing job. If they'd had a live informant, of course, they would have used the live informant. But there's another point about historical linguistics. Unlike structural linguistics, historical linguistics looked for explanations. I was, just as an anecdote, I was pretty much struck by this back in the 1940s when I was a student. What was really struck me as pretty exciting that things like, say, the Indo-Hittite hypothesis were able to explain the appearance of elements that you found in the existing languages by postulating an element that didn't show in any of the languages. Those of you who know this work will be familiar with it. Back in the 40s, I read about it in Sturdivant's work. None of that was taught at the time, but it was really explanatory. And in fact, just personal anecdote, my own first work, Morphonemics of Modern Hebrew, was actually based in part on historical Semitics. And you may know there's two versions, of undergraduate thesis and a master's thesis, which was then published. The difference between them, which is considerable, is based on a suggestion by close friend, an Israeli logician, Yehoshua Bar Hillel, the only person who actually read the undergraduate thesis. And he suggested something that turned out to be very important. He said, for the underlying forms, why don't you use the Proto-Semitic forms? It seemed like a pretty exotic idea, but when I tried it, turned out to simplify things enormously. You got much deeper explanations for the synchronic description. So the second version, the published one, is much simpler than the original. Actually, Morris and I pursued this later. You look at sound pattern, it's based on pretty much the same idea. There were real explanations in historical linguistics, unlike structural linguistics, which eschewed explanation, was not a topic. And it turns out it can be a hint to better descriptive work. It's one of these cases, interesting cases. It shows up today in work that's being done on parameters. So Pino Longobardi, who's now at York, has been doing very interesting work on a study of comparing the historical conclusions. If you just, there is work, genetic work, Kovalos Forti and others who've tried to show with genetic analysis, you can find something about the history of languages, interesting work. Pino has shown that if you just trace commonality of parameters, which ones are shared, deeper ones are shared, more peripheral ones that aren't, just trace this carefully using the methods pretty much of evolutionary biology, you get a better account of the history. It's quite interesting work, definitely worth looking into. So I think there's a lot to say about this. There's also really good work by now on diachronic linguistics using parameter changes and so on. But the striking point, which is worth bearing in mind, is that historical linguistics did aim for explanation, unlike structural linguistics, behavioral linguistics, data science, which have no interest in explanation. A friend of mine who's a quantum physicist sent me a paper that appeared in a quantum theory journal, came from Silicon Valley Science. It was a paper that suggested that physics could eliminate the search for explanations, just do massive study of data, find all the patterns you can with deep learning, and then that'll give you the theory. You don't need to, that'll give you the output, the predictions you want, so we can get rid of the theory. So why try to understand anything? It's a point of view, I guess, pretty remote from science.
I think we have time for one more question from Norman.
Noam, thank you for the talk. I wanted to ask you a question about the no tempering condition. I took you to be using the no tempering condition to rule out movement into a theta position. The idea, I guess, was that you can't change the interpretation of a phrase by moving it once its interpretation has been fixed. And I guess I just wanted to ask about that idea, because there are people at least talk as though there are cases where you do change the interpretation of a phrase by moving it, as when, say, you WH move into a scope position or something like that. Are these just different types of interpretation, or am I interpreting the idea wrong?
I think we have two quite different concepts of interpretation. It's called sometimes duality of semantics. There's a system basically of theta roles and extensions of theta roles. The things you find in the theta positions and the secondary semantic interpretation that you find in surface subject position and the analog and object raising. So the surface subject position, like in subjective seems, doesn't have a theta role, but it has a semantic role. You see it in sentences like, to seem to be intelligent is pretty hard. It's some kind of secondary role. Then there are totally different kinds of interpretation that show up in this incidentally, I think is the whole A system of A movement. Then there's what you get in the A-bar system, and that looks totally different. It's discourse related, information related, and so on. Just totally different kinds of interpretation. And I think probably the way it works is that language looks at the A system, gives the structure of thought, basically. Then other things go on in the A-bar system, which have to do with how language is used in discourse, and give information about discourse. It's a tricky thing because there are interactions between them, which you have to look at carefully. Incidentally, all across the board here, there's lots of counterexamples. If there weren't, it wouldn't be an interesting subject. I've put them to the side. So for example, take the very idea of sequestering language and externalization. There's plenty of evidence. I see Norman shaking his head, but it's primarily his work, which shows interactions between the two. Well, that's inconsistent with the idea that the language doesn't access externalization. So that is an interesting question. How can we make these two lines of work consistent with one another? It's the existence of such problems that tells you you're in an interesting field. If we weren't running into problems, something would be wrong. Take, say, physics, the most advanced subject. They have some problems too. One problem is physicists haven't the slightest idea what a particle is. Okay, so you can read, I mean, everything's about particles, but you can read articles in quantum theory journals, symposia with people trying to debate what could a particle possibly be. They can't find, I think, somebody can correct me, I think it's 95% of what constitutes the universe. It's got to be there because none of the laws work unless you assume it, but nobody can find it. So a couple of problems. We have some problems too, not that serious, but it's the existence of these problems that tells you you're in a live field. And I think what you're raising is one of them. What is there a sharp difference between the A-bar system and the A system with regard to constructing and determining thoughts? Looks like there is, but it has to be worked out. And if there is, it would provide the answer to your question.
Thank you.
Thank you. We will take one last question from the floor. Could you please?
Hi, Noam. Thank you for the talk. Quick question. So in a sentence, like a very simple sentence, like the cat ran, under your theory, you would think that that would have at the base 3 semantic constituents. But do you think there's a possibility that even a simple word like cat can be further decomposed through merge into an operation between more atomic semantic constituents merged together?
Well, that raises quite a deep problem. What is the nature of concepts? The most elementary concepts, like cat. So suppose something looks exactly like a cat, has every property of a cat, but was actually invented, created by some mad scientist on Mars from who put it together, and it doesn't have the internal nature of a cat. It may act as if it does, but it doesn't really have it. Is it a cat? We don't really have a good answer to that question because our concepts aren't clear enough. They're not, the concepts of ordinary language are not like the concepts of physics or even linguistics. They're not well defined. But when we look at them carefully, they have many very complex properties, including cat. Occasionally, I've written about this a number of times, but just to be brief, let's go back to classical Greece, the first discussion of this topic. So Aristotle raises the question, what's a house? That's his example. Actually, notice he's talking about the thing house. It's a metaphysical question, but it's exactly the same if you look at the word house. As he pointed out, words are just signs of things, and they have the same properties as things. He also thought they're shared among all humans. The sounds are different, but that's peripheral. He didn't take what we call Saussurean arbitrariness, he didn't think was serious. And yes, the sounds are different, but the basic signs are the same, just as the objects are. So then what's a house? Well, in his system, a house consists of matter and form. So the matter of the house is the bricks, the timber, and whatever physical objects it was made of. The form of the house is its design, its intended use, and so on. So something can physically look exactly like a house, but not be a house. Could be a library, could be a stable. Actually, it could be a paperweight for a giant, could be anything, depending on what the form is. Now, a physicist looking at the house can't tell whether it's a house or not, because they can only look at the bricks, timber, etc. But that won't tell you what a house is, not in our concept of house. Same is true of every word you look at, including cat. That tells you something. It tells you that there is no semantics in natural language. There are no words in natural language which refer to mind-independent things. That's the core of semantics, at least semantics in the sense of Frege, Tarski, Carnap, Quine, Montague. Any logician, philosopher talks about semantics. It's a theory of reference and truth. Language doesn't have reference and truth. It has acts of referring. I can refer to a house, but that doesn't mean the word house refers to something. It's one of the reasons, I think what we actually have to say is that language has, I was kind of hinting at that when I said that formal semantics should be regarded as logical syntax. It's manipulations of symbols, which is syntax technically. It only becomes semantics if it reaches the outside world. We talk as if it does. So model theoretic semantics, say, sets up individuals and predicates of individuals. But if you look at the individuals, they're just mental objects. They're not things in the world out there. So it's not a criticism, it's just a description. Same is true of event semantics, which I mentioned. Events are not really things in the world, they're mental constructions. If you ask yourself, how many events are there? When I walk across the room, well, there's a gentleman named Zeno who told us some time ago there's no answer to that. Depends how we decide to look at it, you know. So there's immense internal computation going on, which we use in various ways to deal with the world. But that using the internal system to deal with the world is, you can call it pragmatics if you want, but in any event, it's some interaction between organisms like us and whatever is out there. But that's not part of language. And so getting back to the question, I think when we begin to look at these elementary concepts, we find extremely interesting questions. To just give you one last example also, actually the oldest example ever discussed to my knowledge, pre-Socratic, Heraclitus. He asked a very deep question. He said, how can you cross the same river twice? Second time you cross it, it's a different thing, made of different objects, looks different. What makes it the same river? Well, that raises the question, what's a river? Tricky question. On my way to work here in Arizona, I crossed something called the Relito River. I've never seen any water in it. I'm told by older residents that if you cross it during the monsoon, there's water in it, but I've never seen it. But it's the Relito River. What makes it a river is a mental construction having to do with history and what happens occasionally and so on. That same object could be turned into a road if it had a line painted down the middle and it was used for commuting. Same object, but a totally different concept. And if you play with it, it gets pretty arcane. What we understand concepts is very complex. There has been almost no study of it. The reason is another dogma, referential dogma. It's assumed almost universally that words refer to things. And that's why you have books like Quine's Word and Object. There's a word and there's an object and an association between, like the causal theory of reference. Fodor and Lepore, for example, assumes always that there's a word-thing relation, but there isn't. There's the use of words to refer to things, but those are actions, not relations. This actually was understood by Oxford philosophers in the 1950s, but it's mostly overlooked by now. There are people who are working with it, Paul Petrosky, Barry Shine, a couple of others, but mostly the dogma is just accepted. And as a result, there's been practically no investigation of the concepts involved. And it gets pretty tricky when you think about it. So take a simple sentence like, the book is easier to lift than to understand. Well, what entity in the world can be both lifted and understood? No real world entity, obviously. That's polysemy, it's called. And it's ubiquitous. But it gets much harder when you proceed. Let's just take the part about the book being understood. What's the book? Is it a thing with covers and pages? Not necessarily. You could have a thing with covers and pages which isn't a book. The kind of thing they had in Victorian libraries, where they were pretending to have libraries, but there was nothing inside on the pages, or maybe just squiggles on the pages. It's not a book. In fact, it doesn't have to be physical. You can have a book in your mind. So it's some configuration of some configuration inside your brain. That's the book. I mean, when you start exploring it, it gets wild. And that's the way every word is in the language. So when we start, if ever this becomes a topic to study, there'll be a lot to discover. But it's not going to be studied as long as you keep to the referentialist doctrine, the word and object doctrine. So in any event, there's lots of things to be studied if you really want to plumb the depths of language and thought. We're barely on the surface.
Thank you. I'm sure we have a lot of great questions, but I'm afraid that is all we have time for today. So thank you, Noam, again. Thank you.